please record. Yeah. Thank you. Hi, everyone. Welcome to PMRO's free webinar on Introduction to Linear Scheduling. I am Puriya Amiri, a senior consultant with PMRO. This webinar will be approximately 30 minutes, and we are going to review the definition of the linear projects, concepts of linear scheduling, some characteristics of time location charts, and a brief comparison between the Gantt charts and time location charts. There's also a Q&A session at the end, so you're on listen-only mode. So if you have any questions, please use the chat box. First, an introduction to PMRO. PMRO has been offering project management services to different sectors for more than a decade. And to support our clients, we are partnering with some of the industry leaders of project management information systems. Our consultants with field-proven expertise contribute to client successful project delivery. As a Canadian project management consultant, PMRO has been a trusted partner in providing comprehensive scheduling solutions, claims and risk management services, as well as project intelligence and tailor-made project dashboards. So, what is a linear project? Linear projects are the projects where work occurs over a linear alignment repeatedly or continuously. Examples of linear projects are roads, tunnels, railways, pipelines, power transmission, etc. The work can also interact with fixed locations along the alignment, like bridges, stations, etc. The linear alignment can be either horizontal or vertical. Therefore, high-rise buildings can also be considered as linear projects. As a sample example, assume that we are going to build a road from point A to point E, and also this road has a bridge over this river. From a very high level, our construction project has two WBS, one for the bridge and the other one for the activity, for the road activities. And the road construction has three activities: base course, binder course, and surface course. If we want to compare the critical path method versus linear scheduling, in the critical path method scheduling, or CPM scheduling, we use the work breakdown structure, and the location of the activity is embedded either in the WBS, like location A to location B of the county road, or in the activity name, like base course of the location A to location B of the county road. Therefore, that location is either embedded in the WBS or the activity name. Gantt chart is used to visualize the activity start to finish and duration. Therefore, here we have the activity and duration. In linear scheduling, we extract the activity locations, all those repetitive locations, and display them in a hierarchical manner called the location breakdown structure, or LBS. And then we combine the LBS with the activity type in conjunction with the WBS. The example is for the location, we say location A to B of the county road, and the activity type in this case is base course. Time location chart is used to visualize the activity type and its location at any time during the project. Here, we show the time on one axis, like Y, and location on another axis, like X. Then the activity is drawn on the graph starting from the start time and start location, and it is extended to the finish time and finish location. So here, the difference between the start time and finish time is the activity duration, and the difference between the start and finish location is the distance of the activity. Therefore, here in the time location chart, we have location, activity, and duration. Now, let's compare the Gantt charts with time location charts. In the Gantt charts, between the location A and B, the base course activity starts here and finishes there. Now, for the percent complete, we know the exact time when the activity has reached, for example, at 30% completion, because this is the start and it is the finish. So at 30% completion, we know the exact time. However, we don't know the exact location of the activity at 30% completion in the Gantt chart. Now, in the time location charts, for the base course activity, we know the start time and finish time. Also, we know the start location and finish location. Besides, for any percent completion, we know the exact time and the exact location of that particular percent completion. Furthermore, for that activity, we can say what would be the corresponding location and percent completion at any given time, and vice versa. As we said, in the time location charts, the difference between the start and finish times of any activity defines the duration of that activity. Therefore, for a fixed distance, the activity slope is an indication of the activity duration. Sharper slope, if we fix this distance, sharper slope means higher duration, and lower slope means shorter duration. Now, changes to the activity, to the slope of similar activities are indications of the productivity changes during the course of the project. That might be due to changes to the resources, calendars, learning curves, or even location-specific characteristics like changes in the geotechnical properties. So here we see that for this base course activity, the similar activity, the duration of this base course activity from location A to location B is the same duration of the same activity from location B to location C, which is a higher distance. It's a longer distance. This means that the productivity has changed at this point. So the slope is the representative of the changes in the slope. Similar to Gantt charts, lag is represented as time buffer between the finish of an activity and start of its successor. Now, a vertical activity in time location chart means an activity that is done at a fixed location. like the bridge in our highway example. Assume we want to finish the construction of the bridge at this location, and then we complete the base course activity, the base course of the road pavement from A to C. But the time location chart shows that there is a clash at this point, which means the road pavement activity will reach this location before the construction of the bridge is completed. So if we don't want to touch the productivity corresponding to the slope of this base course activity, there are a few options. Option one is to split the road pavement activity into two activities with finish to start logic. Therefore, the base course activity 2 is tied to bridge, and base course 1 with finish to start. Therefore, these two activities should finish with a time lag, and then base course 2 activity is started. This method prevents the clash, but this method prevents the clash. But on the flip side, the resources should be utilized elsewhere during this time buffer once this activity, the base course activity 1 is finished and the base course activity 2 is started. Another option is that we shift the start of the activity, the base course activity, to a later date. This also prevents the clash, but it may jeopardize the critical path should any delays happen to this activity. But the method to use to control the time buffer between the activities, this time buffer, considering their individual production rate, is called line of balance. That has its own calculations, which is out of the scope of this webinar. If this line of balance method is used, we can keep the original start date and finish the activity at a later date, making sure that this gap is there between this time buffer is there between the bridge construction and base course 1 activity. But if we don't use the line of balance method and we only use the critical path method scheduling, control of this buffer is still difficult. The fourth option is to reduce the production rate, split the base course activities into two activities, and use the finish to start logic to tie this activity to these two and control this time lag. In the time location charts, we group the activity types together and assign shape codes to every activity type. Therefore, here these boxes, this green box is the bridge activities, and the yellow boxes are the base course activities. And there are different activities, but the activity type are grouped together and all represent the base course activity. And then these arrows, red arrows, are the binder course activities, and the dotted blue lines are the surface course activities. And these activities, we can see that, for example, the base course of road A to B and point A to B of the road and point E to D start simultaneously and proceed to the bridge. You can compare different schedules like the monthly updates with previous month schedule or the baseline schedule by overlaying them on the same chart. For example, here, these gray lines, gray shapes are the baseline, and the colorful lines are the monthly updates. So we have overlaid them. We can compare them. We can also display the progress on the time location charts. For example, on this data date, we can see that this activity, this was supposed to start, but it has not yet started, this base course activity. The bridge activity has started late up to this data date. And this base course activity has started late and also with a lower productivity. This slope is changed. With the current slope, this base course activity is going to finish at this time rather than here. So if we can work on based on this time location chart, we can work on a recovery schedule. For instance, increasing the resources or working overtime to change the slope from this point and extending to here to make sure that this activity is finished at the original planned finish time, which is here. Having said that, as a comparison between the Gantt and time location charts, in Gantt charts, we can display a limited number of activities on each page. So a typical highway project, for example, the Gantt chart report can be 50 pages plus long. And it is not easy to track the locations of the activities during the course of the project. And also it is difficult to monitor the activities clash. Whereas in the time location charts, we can display thousands of activities on a single page. And also the locations and clash of the activities can be easily tracked and monitored. And the time location chart is also good for resource and crew management. And nevertheless, I should emphasize that linear scheduling and time location charts do not replace the critical path method scheduling and Gantt charts. And it complements the other scheduling methods and should be used in conjunction with other tools. For instance, critical path methods or CPM scheduling and Gantt charts are based on the work breakdown structure and is driven by the scope or phase of the project, whereas the time location charts are mainly driven by the physical activities. Therefore, they should both used along each other, with each other. There are two approaches to produce time location charts. In the first approach, we use a sophisticated linear scheduling software like Tilos to develop the schedule and consequently produce time location charts from scratch. And these softwares are very expensive and their training are extensive. The second approach is to merge the concepts of WBS and LBS in the conventional scheduling tool, whether it is like P6, MS Project, Excel, etc. And then we use those data to produce the time location charts in a much simpler tools provided by third parties like TurboChart, Power BI Visuals, Excel add-ons, etc., to produce the time location chart. Many clients prefer the second approach because in that case they can have both their usual CPM scheduling tool and also the time location charts. Besides, those tools and add-ons of the second approach are much cheaper, and they don't need that much of training. You can learn them easily within hours as compared to the option 1. I hope you are now familiar with the concepts of linear scheduling. In our upcoming webinar, we are going to present 2 useful tools of the second method, which we just explained. One is TurboChart and the other one is Apex Linear Schedule Visual for Power BI. Follow us on LinkedIn or visit our website at www.pmero.com to register for the upcoming webinars, and stay tuned. Now we have around 5 to 10 minutes for the questions and answers. If any questions are not answered here, you can contact us so that we can get back to you.
Thank you so much for your help.
Thank you. Thank you. My pleasure.
Thank you, everybody.
Thank you so much.
Thank you. It was a pleasure.
Have a great day, everybody.